So we are going to use synthetic substitution today in conjunction with the factor theorem and the remainder theorem. So we can actually use the synthetic division to evaluate polynomials. So before we were using them for long division, okay, now we're going to use them to evaluate. So normally if you have to evaluate a value for a polynomial, you just plug it in, use your order of operations. You can also use synthetic division. Okay, this process is called synthetic substitution. Okay, because it's where you're plugging this in. Okay, and the solution is interpreted differently than when we are doing synthetic division. Okay, and this is explained by the remainder theorem below. So it says if the polynomial function p of x is divided by x minus a, that's just your divisor, okay, then the remainder r is, and they call it p of a. So just remember that there are these certain notations that mean certain things. Okay, p of a is the output. Okay, when you plug in the variable a. So they're using a instead of an x here. Okay, so the remainder is your output. So we're going to look at this example to help us understand the theorem a little bit better. So what this is, this says divide. What we're going to do is evaluate p of x when x equals, and then if you were to solve this, x minus 3, remember how we had to set it equal to 0 to find what we were going to plug in? This means x would equal 3. X minus 3 equals 0, you add 3 to both sides. Okay, so if you did synthetic division, they just put the 3 here, you drop the 1 times 3, okay, you go through the synthetic division process, and this is your remainder. Your remainder is 7. Okay, we're going to see what happens when you do the direct substitution. So direct substitution is what you're used to doing. If you are evaluating p of x when x is equal to 3, you're just going to plug in 3 to your polynomial. Okay, so your polynomial is x cubed minus 4x squared plus 5 times x plus 1. So if we're doing direct substitution, we're going to plug in 3 anytime we have an x. Okay, so I want you guys to use your order of operations to solve that without your calculator. Remember, you do your exponents first, then we multiply, then we add or subtract. Okay, so what's 3 to the third power? 27. Okay, for the next one, you have to do 3 squared first. Okay, so you are doing 4 times 9, which will be negative 36. Okay, 5 times 3 is 15 plus 1. I usually will add these together to do plus 16. Okay, and then you can go from left to right, or you can do whichever order is easiest for you. Sometimes I'll add these together first, right? So negative 36 plus 16 would be negative 20. 27 minus 20 is going to give you 7. Okay, so using synthetic substitution, the remainder is the same thing as your direct substitution. All right, so this is another way to use this that can be a little bit faster. Okay, so what is p of x? When they're talking about p of x, they're just talking about some polynomial. Okay, and what does the term P of A mean? I put it there for you. So the output when you plug in A. Okay, so it's the output when you plug A into P of X or into the polynomial. Okay, that's what the theorem is telling you. All right, so in example 1, you are going to use synthetic substitution to find f of -2 and f of 4 for each function. Okay, so I'm going to do the first one with you, and then I'm going to let you give it a go. So remember that you do have to put in your placeholders. Okay, negative f of -2, you're plugging in -2. And then you're going to put the coefficients along the top. So 2, 5, -1, 7. Okay, go ahead and do your synthetic substitution there. Okay, and then when you're ready, you can also do 4. Okay, so we're doing all of this without our calculator today. And then there's a special way that you're going to write your solution. So first we'll just check to make sure you got the right values. Remember, a negative times a negative is a positive. Okay, so your output is the remainder. The way that you're going to write it is function notation. So we would say f of -2 is equal to 13. Okay, so we're not writing it out in long division anymore. We're using substitution. All right, and then you guys had to do the same thing for 4. Do you guys need another minute to complete that one, or are we good? Okay, so 2 times 4 was 8. Okay, when you're doing these bigger multiplication, remember you can do 4 times 10, which is 40, and then 4 times 3, which is 12. So 40 plus 12 would be 52. Okay, and then here, what's 4 times 50? 200, and then 4 times 1, 4. So you just add them together, 204. Okay, so I want you to try to write the form of your answer there. Okay, and then for part B, again, we're doing the -2 and 4. So when you're setting this up, you have x to the 4th, -25x cubed. There's no x squared, so you do have to put in the 0. So if you miss that, you can go back. Okay, and you always drop that first one there. Okay, and if you need to do any multiplication to the side, that is fine. All right, let's see how our mental math skills are going. Okay, so you have negative 12, so then you add them together. Remember, a negative times a negative is a positive. Okay, and then here you're just doubling them. Adding straight down. Okay, and then you double, so a negative times a negative is going to be a positive. And then you're going to write this in function notation. Alright, and then here we should have 24, which brings this to a negative 1. And then another thing you could do is you can always do, probably like the 4 times 10. I was going to say 4 times 20, and then you can subtract the 4. That would be another way you could do it. Sorry. Okay, so you have f of 4 equals negative 71. Alright, and then we are going to do an application. Okay, for synthetic substitution. So the revenue from a streaming music service in the United States from 2005 to 2016 can be modeled by the following function. Okay, where X is the number of years since 2005 and Y is the revenue in millions. Okay, so it says estimate the revenue from the streaming music services in 2010. Okay, so the first thing we have to do is find out what your X value is going to be. So we have to estimate the revenue. So that's the output because that's your Y. If it's in 2010, what is your value of X going to be? 5, because from 2005 to 2010. okay, would be 5 years. Okay, and we are going to write these. And again, just give yourself some space. Sometimes I'll just write in first so I can give myself an adequate amount of space. So 0.26, negative 7.48. So I have 5, 4, 3, 2, 1, and then the last one. Okay, and then 5 is going to be our value. Okay, so we have 0.26. For the decimals, you guys can use your calculator for that, for the application.
Will it be a calculator?
Yeah, there usually is. But if it was on no calculator, then you wouldn't have something with decimals. Right, so fill that in. I'm going to have you fill it in with me. If you need a calculator, let me know. All right, what would you get for this first blank here?
1.3.
So you said it so excitedly before. 1.3. All right, and then Kobe, what'd you get when you added? Great. Okay, and then Noah, what'd you get for your next blank here?
Negative 7.9.
Nice. Okay, and then Cam, what'd you get for the next one?
48.
Good. And then Elliot for this one.
241.5.
Nice. Avian, what'd you get for this one?
Negative 91.8.
Great. And then Carson, what'd you get for this one?
Negative.
No, you can tell me, Chris.
Negative 459.6.
Good. All right, and then Bella, what'd you get when you added? Okay, go ahead and do it, and then okay. Great. And then Elijah, what'd you get for this blank?
112.65.
Nice. Okay, and then Haley, what'd you get for the last one? Great. Okay, so you're trying to find the revenue, and then they tell you that this is the revenue in millions. Okay, so when it says estimate the revenue, you're going to write this in millions, or you can multiply. So you can either say 211.78 million, or you can just multiply that by a million in your calculator. Okay, and then you can put all the zeros with it. That would be fine too. Okay, just make sure that your unit matches the ones that are given. Yep, for the application, it just says estimate in 2010. So in that case, you can just interpret the answer. No. Nope. All right, and then the other theorem we're going to learn today is called the factor theorem. Okay, so remember, when something is a factor, like what are the factors of 12? 2, 6, 1, 12, 3, 4. So what does that mean when they're factors? They divide into it evenly, right? Okay, so if they divide into it evenly, that means there's no remainder when you divide. So the factor theorem tells us that a binomial is a factor of the polynomial if and only if the remainder is 0. Okay, but the way that the factor theorem writes it is they say P of A equals 0. Okay, so we know that that means the remainder equals 0. No. Okay, the remainder equals 0 when you perform synthetic division. Okay, and when you are performing that, just remember the leading coefficient must be 1. And if it isn't, then you have to divide by the leading coefficient. Okay, so if not, divide by the leading coefficient. Okay, so we're going to do an example of this together. So the way they're going to give this to you is they're going to give you the binomial, and then there's going to be a semicolon with the polynomial. So you have the binomial, that quantity's in parentheses. Okay, same thing with the polynomial, similar to when we were doing the division. So if we want to see if this is a factor, we set that equal to 0 to find what we're going to use in our synthetic division. We're going to line up the coefficients. So 1, -1, -30, 72, and then -6 is going to go on the outside. Okay, I'm going to give you a moment to do that synthetic division. We're going to go over the different forms. Okay, so once you do your synthetic division, think about this theorem and how that's going to relate to your answer. Okay, so you did get a remainder of 0. If that happens, according to the factor theorem, that means x plus 6 is a factor of the polynomial. If you get anything other than 0, then it would not be a factor. Okay, if it's a factor, it goes into it evenly, which means your remainder is going to be 0. Okay, so for our next example, it says that you are given a polynomial and one of its factors. You have to find the remaining factors of the polynomial. So we're going to start off with this, but we're going to have to go another step further. Okay? All right, so you are given the polynomial and you are given one of its factors. Okay, similar to what we just did in our example, it's just a different order. But we're still going to use this as the divisor, and we're still going to do synthetic division. Okay, so for your divisor, you can always set that equal to 0 to find what you're going to use in synthetic division. Okay, keep in mind that you need to put in placeholders if you have a missing term. So I have 1x cubed, I don't have an x squared, I have negative 3 in front of x, and then a 2. Okay, so we're going to do our synthetic division like usual. 1 times negative 2, add straight down. Multiply across, add straight down. Multiply across, add straight down. Okay, now it did tell you they were one of, that this given was one of the factors, so there's no way you shouldn't get 0 there when they tell you that. And then if we find the remaining factors, that means we can write this as a polynomial. If this is the remainder, this is the constant value or the number term. This is the coefficient of x. This is the coefficient of x squared. So you have x squared minus 2x plus 1. And to find the remaining factors, all you have to do is factor this. Yeah, factoring is never going away. Okay, so this one's pretty simple because it has to multiply to x squared, so it has to be x and x. If you multiply to a positive and add to a negative, they both have to be negative. The only thing that multiplies to 1 is 1 and 1. Okay, so the remaining factors, I put remaining factors. Okay, you can either write as x minus 1 or x minus 1, or you can write it as x minus 1 squared. Okay, either one is fine. Okay, you can combine them or you can leave them. All right, so then based on that, let's try B. We have 3x cubed plus 4x squared minus 5x minus 2, okay, and then 3x plus 1. Okay, so remember, whatever your divisor is, the leading coefficient has to be 1. Okay, so if it doesn't, then we have to divide everything by 3, not only here, but also here. Okay, and when you're dividing by 3, if you just want to set those up in the synthetic division, that's fine. Okay, I'll give you a moment to divide everything, and then we'll check that. Okay, so 3 divided by 3 is 1, 4 divided by 3 we keep as a fraction, negative 5 divided by 3, make sure you keep the negative, and then negative 2/3. All right, so then when we multiply, we get negative 1/3. Okay, when you are adding fractions, you need a common denominator, and then you just add or subtract the numerators. So if 4 minus 1 is 3, 3 divided by 3 is going to reduce to, what's 3 divided by 3? just 1, right? Okay, so I'm just going to write down 1. Okay, so see if you can do that, reduce. And if you want to write it down and then reduce underneath, you can absolutely do that. Okay, so then when you got negative 6 over 3, okay, that reduced to negative 2. When you multiply by the numerator. A negative times a negative is a positive. Remember, you should be getting 0 there because it tells you that it's a factor. Okay, and then you can write out your trinomial. So you have x squared plus x minus 2. You don't have to set it equal to 0. I know sometimes we do that out of habit. So it has to be a positive 2 and a negative 1. Positive times a negative is negative 2. 2 minus 1 is going to be positive. Okay, so these are going to be your remaining factors. Okay, so they give you one factor, and then you can break it down to factor the rest. Okay? All right, and then I'm going to give you the rest of the time. Work on your assignment. Okay, and then if you need to get the note sheet from last week, that is in the bin for you.